everyone, and welcome to this CoolLIFE tutorial. My name is Giulia Conforto, and I have the pleasure to introduce our expert, Aadit Malla of TU Wien, who will demonstrate the Calculation Module Economic Feasibility on the CoolLIFE tool. Over to you, Aadit.
So now I will talk about the Economic Feasibility Calculation Module, which again is available under the cooling category. So this calculation module works from NOTS 1 level and below, and but provides information on a national level. So if you select any particular area of interest, the calculation module becomes accessible, and when you click it, you can then you get into the input parameter settings, where based on the settings you can then develop results. So for the economic feasibility calculation module, the main idea here is to provide support on identifying measures in terms of passive cooling and active cooling supply to develop different scenarios based on which the user can identify most relevant scenarios, which could then feed into development of policies or assessing for different levels of strategic planning. The economic feasibility calculation module runs on two levels, one on the national level and one on the building level. So on a national level, it takes into consideration of all the different types of buildings available from national level or Eurostat data on the building stock of this particular country in selection, whereas for building level, based on the user-defined building architecture type, the calculation module provides information for this specific type of building, which is ideally designed for a particular building owner. So firstly, we start with the national level assessment, where we have three important inputs. First, on the passive measure efficiency, second, on the diffusion rates of active cooling technology, and third, on the technology efficiency, the efficiency of the active cooling supply technology. And so based on these scenarios are based on different based on different background information and assumptions. So for the passive measures, scenarios, we've formulated two different scenarios. One we call the moderate efficiency scenario, and the other high efficiency scenario, where we do a bottom-up building stock modeling, tweaking different parameters such as the shading activation systems in a building, the number of windows that are shaded, the G value of glasses, the Z factors, the implementation of night ventilation, indoor set point temperature, and also the thermal capacity of the buildings. So the model is implemented such that buildings, whenever they are considered for thermal renovation for heating, also take into consideration these passive measures, and also all new buildings constructed within our study horizon, which is up until 2050, have uptake of one of these passive measures. So these are the two scenarios for the passive measure. And then we have two scenarios for the active measures, where on the left we have the diffusion rate of the technology. So here we consider certain, based on historical trends of uptake of active cooling, for the baseline we see similar trends continuing until 2050, but also we develop two different scenarios where there is high diffusion and moderate diffusion of technologies. And on the right we have the efficiency rates. So we calculated or collected from literature the average SEER seasonal energy efficiency ratios per country, and then based on that we define two different scenarios on high efficiency, which increases the SEER by 4, and a moderate efficiency by 2. We define scenarios in the calculation module. So for the passive measure, you could either choose one of the three. So you have either option of high efficiency, moderate efficiency, or a situation where the passive measure efficiency doesn't change and stays at the status quo. For now, we choose high efficiency. And similarly, for diffusion rates, you have options to choose from high, low, or high, moderate, or stay as it is. And also for active cooling, you have this same options. And then we have these options which are not really needed for the national level assessment, which are, as you can see in the pop-up, available. This is only needed for building level, so we don't use this for now. And then we have some economic parameters on the for calculation on discount rates and also the lifetime of the system. So now you can run the calculation module, which gives results for Austria now because of the selection. And here on the output parameters, we have the country of selection and a brief description on what was selected here, what was put as what was the input here, just to keep, for the user to keep track of the scenario, and shows you what was the average baseline ICER for Austria based on the literature. And in our scenario now, since we selected high efficiency, this has increased to 7.85, and based on that, we can see that with these set of scenarios, there you can expect a useful energy demand savings of 66.35% and a final energy demand savings of over 86%. And with this regards, with the scenario on passive measures, the investments for the passive measures would require about 76 euros per megawatt hour of energy saved, and also for the high efficiency active cooling technologies which we applied, due to high costs of these technologies, the supply costs of the the supply costs for cooling goes to 215 euros per megawatt hour. And the same results can be visualized in the forms of charts here, where on the top we see the comparison of the two scenarios, the baseline if no passive measures and no active cooling technology improvements were done, how the demand increase would look like for different years compared against the scenario that the user has selected. And also here we have the cost on investments, so total cost for all the kinds of building stock, and how the cost investments would change. So here, ideally, you could see that within higher investments in the passive measures, you could drastically reduce the variable operation cost, which is the orange bar here, which represents basically the cost for electricity. And here we have also at the bottom the comparison of the levelized cost of cooling again for baseline against the selected scenario. So for the baseline we have only the supply costs, but for the selected scenario we have investments on savings as well as the selected for the upgraded active cooling solution. I mean, we see that now here the costs have increased because the active cooling solutions which are of high efficiency are a lot more expensive, and as a result this leads to higher supply costs. But more importantly is the fact that the electricity consumption drastically reduces, which contributes to a lower strain on the grid due to peaks of cooling load, and also better environmental performance. So that was the national level assessment, and we could do the same assessment for same level on a building level, so without changing the passive measures. Now let's say we have options to select different types of buildings for based on the data available for this particular country. So let's stick to a single family household with a total gross floor area of 400 meters squares and same financial input parameters. And when you run the CM now, it's already finished. So now the scenario is changed to it's been done on a single family household in Austria, and also similar trends. Here we see a useful energy demand savings of 60% and final energy demand of 80%. And investment per euro of megawatt hour energy saved would be about 29 euros, and the supply cost of about 71 euros. Per megawatt hour. And similarly, the results can be visualized on on charts. So here, rather than on national assessment where we do forecast for a predefined horizon period, we just here focus on a particular year and how demands would change and what it would mean for a building owner in terms of costs. How you can see here with minimal investment in passive measures, which shown by the orange block here, the investment or the annual expenditure on electricity drastically reduces, which would be a good, and hence the investment of passive measures would be a good option for the building owner. So similar assessments can be done for any region, and this could provide feedback for the building owner to make decisions on their investment.
And that brings us to the end of this CoolLIFE tutorial. We hope you have enjoyed it, and please don't forget to look up the links in the description for more information.